Video we will discuss about topology. So topology is not a very difficult topic. We will start with the basic and we try to give some time to understand what is topology meaning. Suppose we have given one set X. If we collect all the subsets, or you can say all the subset is a very trivial thing. So if we collect subsets of X and say we are collecting the subset in another set which is called T. So we have new set T, and if that set T is satisfying some properties, then T is called the topology on the given set X. So what are these axioms or properties? That the whole set X and phi should belongs to T. Second, arbitrary union of subsets of T should lie in T. Another property is finite intersection of subsets of finite intersection of subsets of X, that is also X. T is nothing but the collection. So if we choose arbitrary union from the T, that should lie also in T. Similarly, if we choose finite intersection of subset of X which is actually in T, that should also lie in T. So if this axiom holds, we will say that T is topology on X and X comma T is called topological space. Now let's understand this by an example. So suppose we have set X which is ABC. Now we will collect subsets X, Y, intersection A, intersection B, and we will collect, sorry, not intersection, we will collect X comma Y comma singleton A, singleton B, and AB. Now we need to check, is T makes a topology on X or not. So clearly X and phi are in T. Next, if we take union of any two sets, suppose we will take union of A and B, we will get A comma B which is already in T. If we take union of X and A, which is nothing but X which is already in T. So you can see that if we take any union, that will lie inside T. Next, take intersection. Suppose we will take intersection of A comma B, intersection B, that is A, that is also lie in T. Similarly, if we take intersection of A, B and A, that is B, that is also lie in T. If we take intersection of X and AB, that is AB, it is also lie in T. If we take intersection of X and A, this is singleton A, again lie. So we will see that all the properties hold. So this T forms a topology on X and Xt is called topological space. Let's check example 2. That X is again A comma B comma C. T equal to X comma phi, singleton A, singleton C. Now similarly x and phi and t. Now when we take the union of A union C, this should be equal to A comma C, but A comma C is new set which is not lie in T, so this T is not a topology. G on, I hope you understand that if any collection of subset of the given set satisfy the three properties, then that collection of set become a topology on the given set. Also, if T is a topology, then element of T is called open set. If T is a topology, then that called a open sets. Now take another example. See, so if we collect, if we have given x, which is a comma b comma c, and if we collect t as only x comma phi, so clearly x and phi in t, intersection is also in t, union is also in t, so this become a topology, and this is called in discrete topology. Similarly, if you take x is abc and collect all the elements, all the subsets of all the subsets, you can say power set of x, so this is also a topology, because the union of any two sets is again a new set which is a subset of x, and since we are taking all the subsets in t, then it is again lie in t. Similarly for the intersection. So I hope this basic idea of the topology is clear. Next, what we can define, we can define some other example as well. Let's go to the next page. Next we will define a topology, or we can say example. If x is a non-empty set and t star is defined all the subset u such that x minus u is finite, union phi, so this t star is a topology. You can check all the properties. Topology on x, and this is called complement finite, or you can say co-finite topology. So clearly you can see the whole set x will be inside, because if you take u equal to x, so x minus x, which is phi, is given in the set, so it is inside. Phi is actually a finite also. Similarly, if you want to check phi, so x minus phi is equal to x, and the complement is finite. So clearly phi is already there, we do not need to check for the phi, because phi is already we are taking for in the union, so phi is automatically inside the t star. Similarly, if we take any union, that is also lie in t star. If we take any two sets whose union also lie in this t star, and intersection is also lie in t star. Similarly, you can define more and more topologies. Next we will discuss one more topic and then we end this lesson. So we know that we can define more than one topology on the given set. So if t1 and t2 and t2 are two topologies on x, then the sets of T1 is called open and sets of T2 is also called open. So if every set of T1, suppose T1 is containing set X, if X belongs to T1, its X is also in T2. This means T1 contain in T2, then T1 is called smaller than T2 and T2 is called finer than T1. So with this we will work with one example. So let X equal to ABC and T1 we will define X comma phi, which is our discrete topology, and T2 we will define A comma X comma phi singleton A singleton B AB. So clearly X and phi inside T2 also, so we can say that T1 containing T2 and T1 is finer than T2 topology. Thank you. We are ending this video now. If you have any doubt, you can ask in comment box.